Hello and welcome. This is Bijan Hushiar. This internet network is configured as dual stack with both IPv4 and IPv6 addresses. However, end-to-end connectivity is not established yet. No routing has been configured. Router 1 is only aware of the two networks attached to its G00 and serial 000. It is not aware of the network attached to G00 of router 2. Router 2 is only aware of the networks attached to its serial 001 and G01, and it is not aware of the network attached to G00 of router 1. Therefore, there is no end-to-end connectivity. We want to establish end-to-end connectivity in this internet network by configuring default static route. So we access router 1's command line interface. We go to privilege mode. We perform a couple of show commands. Show IP interface brief to display IPv4 addresses that we have assigned to G00 and serial 000 of router 1. If we perform show IPv6 interface brief, we are going to be able to display the IPv6 addresses that we have assigned to G00 and serial 00 of router 1. So as you notice, this router is configured as dual stack. If we perform show IP route, we are going to be able to display the routing table of the router 1 for IPv4 addresses. As you notice, there are two connected routes in this routing table for IPv4 that are the network addresses of the two networks that are attached to G00 and serial 000 of router 1. We perform show IPv6 route, we're going to be able to see the content of the IPv6 routing table of this router. Again, there are only two connected routes as far as IPv6 is concerned, related to the two networks that are attached to router 1. Router 1 is not aware of any remote network, including the network attached to G00 of router 2. Let's go to router 2's command line interface and perform the same commands. We go to privilege mode, show IP interface brief. These are the IPv4 addresses assigned to the two interfaces of the router 2. If you perform show IPv6 interface brief, we'll see the two IPv6 addresses assigned to the same interfaces that we have assigned IPv4 addresses. We perform show IP route. It will display the routing table of router 2 for IPv4. There are two connected networks and designated by letter C. I will perform show IPv6 route. It will display the content of the IPv6 routing table. Again, there are two connected routes related to the two networks that are attached to router 2. Router 2 is not aware of any remote network, including the network attached to G00 of router 1. Therefore, PC1 and PC2 cannot communicate. There is no end-to-end connectivity. In order to establish end-to-end connectivity, we have to configure routing. In this exercise, we are going to start by configuring default static route as a gateway of last resort. So we access the command line interface of router 1. We go to global configuration mode and we perform IP route any network with any subnet mask, send it out of my serial 000 if you've received any packet for any network, okay, with any subnet mask in here, any network, the first four. With any subnet mask, the second four zeros, send it out of this serial interface, serial 000, which is called exit interface. This is the exit interface for packets forwarded by R1 towards a remote destination. So better. Don't worry about this. It says if it is not point-to-point, it may impact performance. You always get that message. There is nothing wrong with getting that message. We have done the correct command. So if we go to router 2, we have to, now with that command, we have opened a way for packets to go from router 1 to this network. But the packets needs to also reach this network from router 2. So we have to go to router 2 and perform a default static route on that one also. From privilege mode, we go to global configuration mode and we go IP route any network, 4 of them, space, with any subnet mask, 4 zeros. You can put either exit interface, which will be serial 001, or you can put the next hop's IP address. Next hop IP address, from point of view of router 2, is the IPv4 address assigned to serial 000 of router 2. What IP address did we assign to that one? If you go back to the router 1 and we perform show IP interface brief, you'll notice that IPv4 address of serial 000 is 209.1.1.1. If we want to use the next hop's IP address in this command, we have to put that IP address, 111. That's it. Now we can go ahead and test end-to-end connectivity. What is the IPv4 address of PC2? Let's check it out. PC2 has this IPv4 address, 192.168.2.1. Let's see if we can communicate with it from PC1. We go to PC1's command prompt and we type ping 192.168.2.1, and we'll wait for the replies, echo replies to come back. 4 echoes are going to be sent, and if you receive at least one of them, the end-to-end connectivity is there. Normally for the first ping, you lose one of the echo replies. As you see, there is end-to-end connectivity. This doesn't provide end-to-end connectivity as far as IPv6 addresses are concerned. We have to configure default static route for IPv6 addresses as well. So we can test that to show you that we need to perform that command. So I'll go IPv6 config /all to find out what IPv6 address PC2 has. Then I copy it to make my job easier. Go to PC1 and see if I can ping it. It should fail. because we haven't configured any routing as far as IPv6 is concerned. We have configured for IPv4. So destination host unreachable, timeout. There is no end-to-end connectivity. So let's go ahead and configure default static route for IPv6. We go to router one's command line interface. This time we go IPv6 route, double colon, slash 0. Send it from serial 0, 0. Send it out from serial 0, 0, 0. So if you receive a packet for any IPv6 address with any prefix length, send it out of serial 0, 0, 0. We are using exit interface in here. So before moving along to the other router, let's find out what IPv6 address we have assigned to serial 000 of this one, because we want to use next hop IPv4 address. From previous show IPv6 out, we can find out about that, and we can also find out about it by performing do show IPv6 interface brief. Now notice that serial 000 of the router 1 has this IPv6 address, 2001 colon db12 double colon 1. Okay, we are going to use it when we configure the default IPv6 static route on router 2. We access the global configuration mode of router 2. We perform the same command, IPv6 route any network. Double colon means all zeros as far as the hex sets are concerned, /0. We want to use the next hop IPv6 address, 2001 colon db12 double colon 1. There you go. Now let's go ahead and see if we can perform end-to-end connectivity using IPv6 address. Here you go. Replies are coming back. That's how you configure default static route. Let's say that we want to remove these default static routes. How do we do that? Very easy. In order to remove them, you just perform the same command with a no in front of it. There you go. No. Before doing that, let me display the content of the routing table. Do show IP route. You'll notice that another route is added to the IPv4 routing table of router 1, designated with S asterisk, indicating this is static default route. If I perform the same command for IPv6, show IPv6 route, you'll notice that there is a static route is added. Static and default are going to be using S as a letter to designate them in the output of the show IPv6 route on router 1. If we go back to router 2 and perform the same thing, do show IP route, you'll notice that a route with S asterisk is added. This is the default route that we added for IPv4 addresses. And if we perform show IPv6 route, you'll notice that additional route is added to the routing table for IPv6. Because of those additional routes, it is possible for PC1 and PC2 to communicate with each other. Now let's go ahead and remove the default static route that we created. We are going to remove the IPv6 default static route that we created on router 1 by putting a no in front of it. That's it, it's gone. Let me perform do show IPv6 route. You'll notice that the route with S in front of it is gone. Right now, there is no end-to-end connectivity between the two PCs using IPv6 address. Let me remove no IP route. Default static route that we created for IPv4 S000. So if I perform do show IP route, you'll notice that the static route, that default static route that we created for IPv4 is gone also. The end-to-end connectivity between the two PCs using IPv4 is not possible anymore either. Let me go ahead and remove those routes that we created on router 2. No IPv6 route, :/0 space, next hop's IPv6 address, and then press enter, removes the IPv6 default route that I created. Let me prove it to you. Do show IPv6 route. Only connected routes are there. Let me remove the other one. No IP route 0, 0, 0, 0, 0, 0, 0, 0, four of them, 4 zeros for the network and 4 zeros for subnet mask. And we use the next hop IP address, which was 209.1.1.1. And if I perform show IP route, do show IP route, because I'm not in privilege mode, do show IP route, you'll notice that the default static route that I created for IPv4 is gone. So that's how you create default static routes and how you remove them. You learned how to configure default static route using exit interface, which is an interface on the router that you're creating the route on. Through that interface, packets are going to be directed towards destination networks. And also you learn how to configure with the next hop's IP address for both IPv4 and IPv6. In addition to that, you learn how to remove the default static route for IPv4 and IPv6. You learn how to display the content of the routing table of a router for both IPv4 and IPv6 addresses. Now that we have learned how to configure default static route, let's use the same internet network and configure static route. In order to configure a static route for router 1, I'll go to its global configuration mode and I say IP route, the destination network address. The IPv4 destination destination network address 192.168.2.0. I want to create a route on this router to reach that destination network. So I put that network address over there, 192.168.2.0. What is the subnet mask of that destination network? It's 255.255.255.0. So I put that over there, 255.255.255.0. What is the exit interface? What is the interface on router 1 that packets has to exit from to reach that destination network? Serial 000. So I put that over there. S000, enter. I get the same message that if it is not point to point, it may impact performance. Fine, I'm fine. So let's go ahead and perform a show command, show IP route, a static route is added to the routing table of router 1. Let me go ahead and perform the same thing on router 2. I go to its global configuration mode. I go IP route. Router 2 needs to reach this network. This is the destination network. That's the network address and subnet mask. So I'm going to put 192.168.10 with a subnet mask of 0. I'm sorry, with the subnet mask of 255.255.255.0. What is the exit interface from this router for the packets going out of this router towards this destination network? Obviously, they have to go out of the serial 001. So that's exit interface. If I want to put next hop's IPv4 address, I have to put IPv4 address of this router. I can use either or. I prefer to go with exit interface this time, serial 001. That's it. Now let's go ahead and test to see the content of the routing table of this router for IPv4. Do show IP route. As you notice, a static route is added. Let's test end-to-end connectivity. This PC has the IPv4 address of 192.168.2.1. Let's see if we can ping it from PC1. Ping 192.168.2.1. Yes, end-to-end connectivity is there. But we haven't configured a static IPv6 route. Let's go ahead and do that. This destination network, as far as router 1 is concerned, that it wants to reach is 2001 colon db2 double colon with the prefix length of 64. Remember that. So we go to global configuration mode of router 1 and we perform IPv6 route, which destination network 2001 colon db2 double colon slash 64. What is my exit interface? Serial 000. Okay, so I have created an IPv6 route on router 1 to reach this destination network by sending packet out of this exit interface. Let's go ahead and create the path back from that network to router 1 by configuring IPv6 route. What destination network? This time, this is the destination network that router 2 needs to reach. So it is 2001 colon db1 double colon slash 64. What is the exit interface that packets should go out of on router 2 to reach this network? Through this one. What is the next hop IPv4 address, IPv6 address that can be used in here instead of the exit interface? The IPv6 address of serial 000 of the router 1, which is, if I can go back to router 1 and perform do show IPv6 interface brief, you'll notice that the IPv6 address of the serial 000 of the router 1 is 2001 colon db12 double colon 1. We can use that in here as next hop IPv6 address 2001 colon db12 double colon 1. Here you go. Do show IPv6 route. A static route is added. helping packets reach the remote network attached to router 1 when those packets are originating from router 2. Let's perform end-to-end connectivity. End-to-end connectivity, first let me copy the IPv6 address of this PC because it's a long one. I go IPv6 config space slash all. Oops. IPv6 config space slash all. And then copy this IPv6 address. And then I go to PC1, see if I can communicate with that PC using IPv6 address. Yes, I can. We have established end-to-end connectivity both for IPv4 and IPv6 addresses using static route. So now you have learned how to configure static route for both IPv4 and IPv6, how to display the content of the routing table for both IPv4 and IPv6 routing tables of the routers. This internet network is configured as dual stack with both IPv4 and IPv6 addresses. No routing is configured. We want to configure routing in a way that only PC1 and server in remote networks from each other be able to communicate and no other devices. In order to establish that type of connectivity, we need to create a static host route on router 1 and router 2. The IP addressing of the server is configured with 192.168.2.2 as IPv4 address, 2001 DB2 :2 as IPv6 address, and for PC1 the IPv4 address is 192.168.1.1. The IPv6 address is 2001 DB1 :2. We can test to see if there is any connectivity between these two devices. As far as IPv6 is concerned, no. Destination host unreachable. And then after that, we test IPv4 connectivity, the same thing, destination host unreachable. So we need to go ahead and configure both IPv4 and IPv6 static host routes. So we go to router 1 and we access the global configuration mode and we perform this command IP route. What destination host do you want to route the packet that you receive? This destination host. What IPv4 does it have? 192.168.2.2. 192.168.2.2. And then instead of the subnet mask, we put 255.255.255.255. You're only supposed to forward to this host, no other host. Instead of the exit interface, it's best to put the next hop IPv4 address. If you put exit interface, it may not always work. But if you put the next hop IPv4 address, it will. So the next hop IPv4 address is the IPv4 address of the serial 001 of the router 2. Let's see what that IPv4 address is. We go to the router 2, privilege mode, show IP interface brief. It's 209.1.1.2. So that's the next hop IPv4 address, 209.1.1.2. That's it. Router 1 is configured. We go to router 2. When we configure router 1, the packets have a path from PC1 to server on the remote network. But in order to configure the the path for replies to come back, we have to configure a static host route on router 2 as well. So we go to global configuration of it, and we create the route, host route with IP space route. What is the destination host IPv4 address? Destination host is PC1 with this IPv4 address, 192.168.1. Let me put that over there, 192.168.1.1. Instead of subnet mask, we put 4255s. And then next hop IPv4 address. What is the IPv4 address of serial 000 of the router? That's the next hop IPv4 address as far as router 2 is concerned. We can verify that by performing do show IP interface brief. Serial 000 has the IPv4 address of 209.1.1.1. We use it in here, 209.1.1.1. That's it. Now let's go ahead and see if there is end-to-end connectivity. We'll go to PC1's command prompt, and we perform ping command. Ping 192.168.2.2, which is the IPv4 address of the server. 4 echoes are going to be sent. We expect at least 1 echo reply back. Echoes are coming back. The static, the host route is configured. Now, what is the IPv4 address of PC2? It is 192.168.2.1. Let's see if PC1 is capable of pinging that one. It shouldn't. Destination host unreachable. Let's see if PC3 can ping server 2. We go to the command prompt of it. Ping 192.168.2.2. It shouldn't. Destination host unreachable must be received because we configured a static host route only to communicate with server 2 from PC1, not from PC3. Let's try it one more time. Not possible. Okay. Let's make sure we have all the configuration correct on PC3. Yes, everything is configured correctly. No replies are coming back because we didn't allow that. Now let's go ahead and configure a static host route for IPv6. We go to router 1. The command is IPv6 route. What is the destination host IPv6 address? This is the destination host. The IPv6 address of it is 2001:db2:2. So we are going to type that over there. 2001:db2:2/128 instead of 64. What is the next hop's IPv6 address? Next hop's IPv6 address is the IPv6 address of serial 000 of the router 1. Let's find out what that one is. Do show IPv6 interface. Do show IPv6 interface brief. IPv6 address of the serial 001 is 2001:db12:2. So let's use it in here. 2001:db12:2. That's it. The configuration is done on router 1. Let's create a path for reply to come back. On router 2, we perform the same thing. IPv6 route. Which host do you want to reach? PC1 from router 2. So the IPv6 address of it is 2001:db1:2. 2, we put that over there, 2001 colon db1 double colon 2 slash 128. What is the exit interface? It's serial 001. But if you use exit interface, it may not work. You're better off to put next hop IPv6 address. What is the next hop's IPv4 address? IPv4 address of serial 000 of the router 1. That IPv6 address is 2001 colon db1 double colon 1. So we use that over here. 2001 db12 double colon 1. That's it. Now let's go ahead and test connectivity as far as the IPv6 is concerned. There you go, replies are coming back. Let's see if PC3 can ping that device. 2001 colon db2 double colon 2. It should not be able to do that. We get the same error message. We'll wait to ensure it is not possible for the two devices to communicate because we didn't allow it. We only created a host route for PC1 and server as far as IPv6 is concerned. There you go. Now let's see what the IPv6 address of PC2 is. IPv6 config/all. Let me copy it because it's a long one. Let's see if I can access it from PC1. Ping space paste. Destination hosts are reachable because we did not allow it. We created IPv6 static host route for communication between PC1 and server 2 only. Let's one more time see if we can communicate with server. Yes, we can. Let's see if we can bring it with IPv4 address 192.168.2.2. Yes, we can. So that's how you configure static IPv4 and IPv6 host route. For this type of route, use next hops IPv4 and IPv6 addresses instead of exit interface. It will make it more stable and it will work definitely. With exit interface, it may or may not work. This internet network is configured as dual stack with both IPv4 and IPv6 addresses. There is no routing. The two remote networks attached to G00 of router 1 and G00 of router 2 cannot communicate with each other. The link between the two routers has a redundant path. There are two links between the two routers. We have purposely done that in order to create floating static route. Floating static route means having a backup route. If the first route on the first link doesn't work, if the link is down, the second static route or the second link will kick in and will still allow packets to be exchanged between the two remote networks. So we have to create two static routes on router 1, one with the exit interface of serial 000 and another one with the exit interface of serial 001, and we have to do the same thing, two static routes on router 2, one with exit interface of serial 001 and another one with the exit interface of serial 000. By default, static routes have a metric. That metric is 1. It's the lowest metric, which makes it more reliable. The only thing lower than that is the local or connected routes, which have metric of 0. With the floating route, we keep one of the routes with the default route, with the default metric. The other one, we give it a higher metric, let's say 5, 10. That way, the router is going to keep the route with the lower metric in its routing table, and it's going to use it unless that route or the link related to that route goes down. Router automatically will add the floating static route that it has with a higher metric, and packets still can be exchanged between the two remote networks. Let's go ahead and start configuring the routes on router 1. We go to uh, privilege mode, show IP route. There are no routes except static routes. Show IPv6 route. Show IPv6. Show IPv6 route. There are no routes except connected ones. On router 2, we can perform the same two commands to verify that there is no route. We go to privilege mode, show IP route, just connected routes, show IPv6 route, just connected routes. 3 connected routes to each router, because each router has 1, 2, 3 networks attached to it. That was router 1. Router 2 has this network, and that network attached to it. So let's go ahead and start floating the static routes by going to global configuration mode of the router 1, IP route. I want to access this remote network. The IPv4 address of the IPv4 network address of that remote network is 192.168.20. So I have to put it over there, 192.168.20 with the subnet mask of 255.255.255.255.0. Exit interface is going to be serial 000, serial 000. I can keep the metric as default and just press enter. But if I do question mark, you'll notice that I can put a metric between 1 to 255. By default, 1 is there even if you don't type it. So I don't type anything and press enter. I created one static route with the default metric of 1. I'm going to create another one. This time it's going to out of serial 0, 1, and I'm going to give the metric of 5 to it. Okay, the command was IP space route 192.168.20 with the subnet mask of 255.255.255.0, exit interface serial 01, metric 5. I go to router 2 and access the global configuration mode and perform IP route. Which destination network do I want to reach? This. What is the network address? The IPv4 network address is 192.168.10. 192.168.1.0 with the subnet mask of, I think this is a 0, not comma, 255, 255, 255, 255, 0. The one that I created with the default metric on router 1 was exiting from serial 000. So the one that I create on router 2 for the default metric must use the exit interface of serial 001. Serial 001, because it's the other end of that link. Then I create a second one. This time I allow it to go out of serial 00 of the router with the metric of 5. Let's perform show commands. Do show IP route 1. The static route is kept in there, the one that has metric of 1. Okay, but I created 2. What happened to the other one? It's floating. It's not added to the routing table. It is there in case this one that is added to the IPv4 routing table is not working for some reason. So let's go ahead and perform a show command in here. Do show IP route 1. A static route is kept in the routing table for IPv4. Let's see if we can ping. From PC1, I want to ping any PC over here. PC2 has the IPv4 address of 192.168.2.1. Let's see if I can ping it. Ping 192.168.2.1. Replies should come back because we created a static route. Reply is coming back. Let's see if I can ping server. Reply should come back. Now, the static route that we created with default metric over this link, the link between serial 000 of router 1 and serial 001 of router 2 is being used. Let's go ahead and pretend that link is down by shutting serial 000 of router 1 interface serial 000 shut. Okay, that link is down. Let's see if we can examine the routing table of this router, see what happened. To show IP route. The other one with the metric of 5 is added. Now let's see if we can still ping. We go to PC1. We can still ping server 2. Can we ping the other PC? Yes, we can. So as you notice, a floating route means a backup route for a second link that you have. If for any reason that link that is your primary link with the default metric goes down, the floating route is automatically added to the routing table of the router. Router still can forward to the remote destination network as we displayed in this activity for IPv4. Now we want to configure floating route for IPv6 in the same internet network that we created floating IPv4 routes. So we go to router 1. From the global configuration mode, we type IPv6 route. What is the destination network? What is the destination IPv6 network? This one, 2001:db2:/64. So we use that one. 2001:db2:/64. What is my exit interface? I'm going to go with serial 000, serial 000. What is my metric? I'm going to keep it as default value. I'm going to recreate the route. This time my exit interface is serial 00 1, and I'm going to assign a value as metric, a value between 1 through 254. Let's give it 5. That's it. This one is configured. Let's go to router 2, global configuration mode, IPv6 route. What is the destination IPv6 network that we want to access? 2001 colon db1 double colon slash 64. So I put that one over there. 2001 colon db1 double colon slash 64. What is my exit interface? This is the one that I'm configuring to match the one with the default metric. The one with default metric on router 1 exited from serial 00. It is on this link. So I have to make this exit interface for this route serial 001 and keep the metric as default. Recreate it one more time, change the exit interface and give the metric a 5 for the floating IPv6 route between the two routers. So perform some show commands. Do show IPv6 route. Static route is added for destination network of 2001 colon db1 double colon 64 with the metric of 1. Okay, so let's go ahead and see if we can ping uh, between the two remote networks. We go to PC1, command prompt, ping 2001 colon db2 double colon 2, which is the IPv6 address of the server. Yes, we can ping it. Let's go ahead and see what is the IPv6 address of this PC. IPv6 config /all. It's this humongous number, which I'm going to copy to make my typing easier. I go to PC1, ping, space, paste. Yes, I can communicate. Let's go ahead and pretend the primary link is down by shutting down serial 000 of router 1, interface serial 000, shut. Now the floating route is going to kick in, allow us to have communication between the two remote networks over the second link. Let's examine the routing table to show IPv6 route, static route. Notice the metric of 5 is added right now to the IPv6 routing table, allowing communication between the two remote networks happen over the second link using the floating route that was there but was not added to IPv6 route of neither of the routers. It was there as a backup in case the primary one goes down. Let's see if we can still have communication between remote hosts. Yes. How about server double colon 2? Yes, we can. So that's how you configure floating route as a backup, which is not going to be added to the routing table, but the router remembers it. If the primary route that you have with a lower metric, in this case, the default metric of 1 for a static route goes down, the link related to that goes down, the floating route will be added. In order to have uh, this type of configuration, you must have redundant links between the two routers. The redundant links have their unique IPv4 and IPv6 addresses. You cannot assign the same network address on two links. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.